Hello, dear students. Welcome to Hybrid Learning. So, welcome back to the series for CBSE Grade 10 revision part. This is part 6 of the video. Let's get started. We will be discussing today question number 26 and 27 from the chemistry part. So, both the questions are of 3 marks, okay? And here for 26, we have the option also. We'll be discussing both for your understanding. First, an element X is stored in kerosene and cannot be extracted from its ore using a reducing agent. X forms an ionic compound on reaction with chlorine. Can we store X in water? Give reason to support your answer. No, we cannot store X in water because it's a highly reactive element, right? So it will catch fire. So give a reason to support your answer. You can write that it is highly reactive and it will catch fire when it is kept like that. Number 2, identify the element X. Now it's very obvious that it's written that element is stored in kerosene. So as per your textbook, you have these kind of exceptional metals. So this answer should be for sodium. Name the process used. Write the equation for the extraction of X from its ore. Okay. Process used means when we have a very highly reactive element, we can extract them using the electrolytic reduction method. Now, since we're talking about sodium, we can use the molten sodium chloride. We can extract sodium from the molten sodium chloride using electrolytic reduction method. Write the equation for the extraction of metal. Okay, now write the equation means we have to write the cathode and the anode equation. So one is cathode and one is anode. Okay, so for your cathode, you have Na plus electron will give you sodium, that's neutral. And here 2 Cl minus is going to give Cl2 plus 2 electron. Okay, or question B. Domes of many buildings in Europe are made up of copper. These domes now appear greenish in color. Why do the domes appear greenish though copper is orange-red in color? Okay, so why it is appearing greenish? Because it is oxidizing itself to basic copper carbonate. That is what is giving the greenish color. Okay. In your opinion, should the copper domes be replaced by iron domes to overcome the problem of change of color of copper domes? Now, we already know that iron has the property or gets rusted, right? When it is exposed. So, the reddish layer of rust will be formed over these kind of materials. And sometimes what happens, it comes out, the rusting part comes out, making the element which is beneath it much more unstable. So if we are replacing dome with these iron materials, definitely the dome will become unstable. We cannot recommend that. But now you can ask, but copper also gets oxidized. Absolutely. Copper is getting oxidized to copper carbonate. But the point is, once it gets oxidized, it forms a protective layer on the substance, which does not allow further corrosion to take place. As a result, that stability factor remains. Though the color changes, but it still remains stable compared to that of the iron material. Next, domes used to be made up of thin sheets of metal. So why did the ancient architect use copper to make domes? So now copper is a metal and it's a highly malleable metal. So that's the property through which we can mold copper into different shapes and we can use it in the dome structure. That is why copper was used to make these domes. Okay, let's go to the next question. Amrita electrolyzed distilled water using the setup as shown in the figure. She was expecting two gases to be evolved at the anode and cathode separately, respectively. I hope you can see the diagram and you can understand that which process is going to take place here. This is electrolysis and electrolysis of water. Suddenly, she realized that the bulb in the circuit did not glow when she used distilled water. After this realization, she added a substance to the distilled water for electrolysis to take place. Answer the following questions based on the information given above. Which gas was she expecting to be formed at the anode and which one at the cathode respectively? So I guess from the diagram, you can understand that what they are talking about. Here, oxygen will be liberated at the anode and hydrogen will be liberated at the cathode. B. Why did the bulb did not glow when Amrita passed electricity through distilled water? Because distilled water is a poor conductor of electricity. That is why the bulb did not glow, because it was not able to conduct it. Which substance was added by Amrita to distilled water to get the expected result? Now, since it's non-electrolyte now, right, we need to make it conducting. So what do? We can add any kind of acid, we can add any kind of salt. So you can take sulfuric acid, you can add sodium chloride to make it more conducting. So the answer for this is Amrita can add, or Amrita has added either an acid, which is sulfuric acid, or a salt, which is sodium chloride, to make the solution more conducting. As a result, she got the expected result. I hope you understood the questions, okay? I'll always suggest you to pause the question, attempt it yourself, and then check for the answers, okay? For such more videos, please don't forget to follow Hybrid Learning. We'll meet you up in the next video. Bye-bye. Take care.